everyone! Welcome back to another planetarium show. My name is Jessica. I am the director of the planetarium, and with me tonight is probably a familiar face if you've been to our streams before. This is one of our students, and I will let her introduce herself.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So tonight we are going to take an adventure through the universe and see as much as we can in about 30 minutes. There is quite a lot going on, a lot of stuff out there, but we're going to show you kind of some of the highlights, some of the major types of objects and stuff that are there. So with that, I'm going to switch on over to our view. There we go. All right. So the program that we're using tonight to take our adventure through the universe is a program called OpenSpace. This is actually a free program. It's a pretty big program though, so not every computer is able to run it, but it is a free program that lets you explore the universe all on your own. And I have provided a link for it in the description in case you are interested in checking out for yourself. So we are starting our adventure at home here at the Earth. And of course, even from our viewpoint here on the Earth, there is quite a lot that we can see up in the sky. We, of course, can see the sun up in the daytime, the moon at different times throughout the day and night over the course of the month. We can see planets up in the sky depending on the time of year and where the planets are. We also see lots of stars, which we have kind of separated into these groups called constellations. And some of these are showing now. Now, the constellations you're probably most familiar with are the Greek constellations, and that is a lot of what's showing right now. But it's important to know that those aren't the only or the kind of quote-unquote right or correct constellations, because every culture has their own stories. They see their own pictures, they use the stars to tell their own tales. And so there is a lot of different ways to interpret these shapes that we see in the sky. Now, of course, if we really want to delve into exploring the universe, we're going to have to leave Earth and start, actually, I'm going to leave the constellations on for a little bit. We're going to have to leave Earth and the confines of our planet. And so as we fly out and away, we can see the moon there orbiting around the Earth. And I will take the constellations off just to keep it a little bit more clean. I'll turn them back on in a minute. And as we keep zooming out, flying away from the Earth, we get a nice view of our solar system. And that's going to be our first stop tonight, but we're not going to spend very long here. One, because we do have a lot to see, but also because we've done entire shows exploring just the planets and the moons in our solar system. So if you want more detail on those, definitely go check out those videos that we have done in the past. But our solar system, as we can see here, consists of our sun sitting at the center. There are 8 planets. We have them split into 2 kind of groups, which we call the inner planets and the outer planets. The inner planets being Mercury, Venus, Earth, and Mars, which are all kind of rocky, small, dense planets. And then the outer 4 are Jupiter, Saturn, Uranus, and Neptune, which we can see are spread really far apart, getting really far away from the sun here. And these are all planets that are very large and not very dense. So they're made of things like hydrogen and helium rather than things like rocks and metals like our planet is made of. Now, our solar system has more than just planets and a sun. We also have, where's that? There we go. We have a collection of objects between Mars and Jupiter called the Asteroid Belt, which is full of asteroids, which are really just chunks of rock that are left over from the formation of the planets. And then we also have out past Neptune, which are not turning on for some reason. I don't know. Oh well, I'm not going to spend too long looking for it. But out past Neptune, we have a similar collection of objects, except it's a collection of icy stuff, which we call the Kuiper Belt. So there is a lot of stuff in our solar system, rather than just the planets and the sun and moons. There are also dwarf planets, which is what Pluto is. These are objects that are orbit the sun and are spherical in shape, but they're just not quite big enough to be called planets because they don't have enough gravity to clear other objects from their orbit. And so along with Pluto, we have 4 other dwarf planets, which are Haumea, Makemake, Eris, and Ceres. But let's keep on going, because again, we have whole shows dedicated to the solar system, so we don't want to spend too much time here. But as we start to make our way even further out, let me turn those constellations back on. So here we are out in the very edges of our solar system. And these shapes of the constellations haven't really changed. They look the same. Because even though we are really far from the sun, we still haven't reached the closest stars. We still have a long way to go before we get all the way out to where the stars are. So let's just keep on flying out. And we're going to go further and further. Our solar system now is unrecognizable. Our sun looking just like all of the other stars out there. Until finally, we start to see the shapes of these constellations just start to change. We are starting to reach the nearest of stars to us. And to give you an idea, the closest star to us is about 4 light years away. A light year being the distance that light travels in 1 year, which is about 6 trillion miles. So we're 4 times that distance away to get to the closest star, and then even further to get to, more distant stars. And so as we keep moving away from our sun, we really start to see these constellation lines changing, because we are now out in the midst of these stars. And it also really shows something that I'm not sure a lot of people realize, that the stars that make up the constellations in our sky are not typically right next to each other as they appear. They're spread far apart with vast distances. It's just our viewpoint from our location makes them appear like they are kind of sitting close together, but they're really spread pretty far apart. All right, so now that we are out in the realm of the stars, we can start to find some other objects that exist out in our galaxy. And the first of these that we're going to look at are groups of stars called star clusters. Because stars tend to form in groups, and a lot of times they stay kind of within those groups, and so we see these kind of groups of stars pretty commonly in our galaxy. And so the first of these clusters that we're going to look at is something called an open cluster. And so all of these green circles are showing us the location of different open clusters in our galaxy. And an open cluster looks kind of like this. So this is the Pleiades cluster. It is probably the most famous of the open clusters. You can see it up in the winter sky near the constellation of Taurus, the bull. And we can see here that an open cluster is kind of a small grouping of a few stars. Not, well, a few meaning, a couple hundred to maybe thousands of stars. But they're kind of smaller groups that aren't really densely packed. They're kind of big, they're kind of these loose groups of stars. And you can see in this particular cluster that these stars have a kind of blue color to them. And that's because what we're seeing here is a very young group of stars. And so we have a lot of these big, hot blue stars that are incredibly bright and outshine all of the other stars that are there and give the cluster an overall kind of blue appearance. Now we know that this is a young cluster because of the existence of those blue stars. These stars don't live for very long. And so they're going to live and die their lives very quickly. So if we see them, we know that we're seeing a young group that's just formed. All right. Now clusters can come in another type other than open clusters. We can also have globular clusters. And so now this kind of yellow circles that we're seeing are showing us the location of some globular clusters. And they are given the name because, well, they look like this. They look like a glob of stars. And that's kind of what they are. It's a grouping of a lot of stars, a lot more than we see in the open cluster. Thousands, tens of thousands, sometimes even hundreds of thousands of stars that are densely packed together in this roughly spherical shape of a glob, and that's our globular cluster. And you'll notice that these tend to be, or what we're seeing here is a lot of the stars tend to be redder in color, or maybe orangish, and that tells us that this is an older population of stars because those blue stars have lived and died, and all that's left are the red stars, which dominate the color, giving us this kind of reddish orange color coming from the cluster. All right. So moving on past our clusters of stars, there are other things that we can find in our galaxy. And in fact, as we look at the kind of band of the Milky Way cutting across the screen, what we're actually seeing here is a lot of gas and dust that's in our galaxy. And there is a whole lot of it. And we call these big clouds of gas a nebula, or plural is a nebulae. And there are different types of these gas clouds out there. Now, one of my favorites are what we call star-forming regions. And you can see that they are really kind of concentrated here in this band of the Milky Way galaxy, because that's where a lot of the gas sits. And these are called star-forming regions because these are stellar nurseries. These are nebulae, gas clouds, where stars are born. And the most famous example of one is the Orion Nebula, which we're seeing here. And it is named so because it is found in the constellation of Orion. It's in his sword, which is also up in the winter. And so there are these huge clouds of gas that stars are born from. And so we see lots of young stars. We also use these to study new forming planets, because as stars form, we have learned that planets typically form around them at the same time. And so this allows us to kind of study and learn about all of these processes involved in creating stars and planets and solar systems. All right, now the next two types of gas clouds that we see are actually the result of a star's death. And we're going to start with probably the most spectacular. And so the very, very largest of stars are going to end their lives in a dramatic event that we call a supernova, in which they literally explode and blast out all of this gas that was once a part of the star. And this gas is really, really hot, and so it glows brightly for a while after the supernova happens. And then sitting at the center, what can be left behind is something called a neutron star or a black hole, which is pretty cool. So these are what we call supernova remnants. And so here are where a bunch of different supernova remnants, we can see that they're all, again, kind of in that plane of the Milky Way galaxy, because that's where all of the star-forming regions are, so that's where stars tend to be born and live and die, and so that's where the big stars are going to have been when they died and reached the end of their lives and went supernova. Now, the supernova that we saw was a simulation of the Crab Nebula, which you can see here now on your screen. The Crab Nebula is one of the more famous supernova remnants because astronomers, or early astronomers, actually saw the supernova that formed this back in, oh, my notes have gone to sleep. I think it's 1066. Lindsay, you can correct me if I'm wrong. I'm scrolling through my notes real quick. 1054. Huh?
That sounded close.
Yeah, it's 1054. In 1054, Chinese astronomers saw this really bright light in the sky, which they called a new star or a guest star, because it was the sudden appearance of a star-like point of light that slowly dimmed over the next few weeks. And then when we found the supernova remnant, because this gas is still moving outward, we can find out how fast that gas is moving and then run that backwards and figure out when the supernova actually happened. And the timing for this fits that time period where the Chinese astronomers saw this guest star in the sky for a period of time. And so we believe that what they saw was this supernova that formed the Crab Nebula here. And sitting at the center is a neutron star. And so this is a relatively young supernova remnant that really lets us kind of study what's gone on kind of not too long after, and can let us watch to see how the gas cloud and how the neutron star at the center have slowly changed over hundreds of years as we've been observing it. And we can see kind of what goes into changing, or what is changing as this gas cloud expands and cools down and all of that sort of stuff. So it's been a really fun system to kind of explore and learn about. Now, our sun is not going to go supernova. Only the very largest of stars end up going supernova. So our sun instead is going to have a little bit less dramatic of a death. So as you can see here, what's going to happen at the end of a star like our sun's life is the outer layers just kind of puff up and get blown away. Not in a giant explosion like we saw with the supernova, but more like a strong kind of wind that kind of blows the outer layers of the star out. But then it forms a very similar thing where all of these outer layers of gas are kind of getting pushed out and away, and you end up forming this gas cloud around what once was a star. And sitting at the center is the dead core of the star, which we call a white dwarf. And so these form what we call planetary nebulas, or planetary nebulae. And so here, with these blue purplish triangles, are the locations of planetary nebulae in our galaxy. And the one that we just saw form is known as the Ring Nebula. Now, the fact that it's called a planetary nebula can be a little bit misleading. It actually has nothing to do with planets. The name came around from when we first observed these through a telescope. They have that kind of circular shape to them and are these pretty kind of bluish colors usually. And so they reminded the observers of planets, even though they knew that they were, gas clouds. And so they're called planetary nebulae because they look similar through a telescope as a planet, but they're not and have nothing to do with planets. So that's what's going to happen to our sun. All right. So let's keep flying on out and take a look at the galaxy that we live in, the Milky Way galaxy. So we're going to fly on out until, why is my model not popping up? 1 second. You're supposed to go. There we go. Sorry, some of my settings got changed. Anyway, so we will take a look at our galaxy. So our galaxy is what we call a spiral disk galaxy. Called a disk because it's shaped like a disk. It's kind of thin, but circular, like a frisbee or a pancake. And then it has these spiral arms in it, which are these kind of patterns that you're seeing moving out and away from the center, which we call the bulge. Now, an important distinction here is this isn't, of course, what our galaxy actually looked like. This is our best model. Because we live inside of it, we've never gotten a view of what our galaxy looks like from the outside. We've had to take what we can see from our vantage point and other galaxies that we see in the universe and kind of make a best model for that. So this is what we think our galaxy looks like. Let me turn on those constellation lines again. And you can see right up there in the top left are those constellation lines. Those are the stars that we see in our nighttime sky. That small little portion. We only see the closest couple thousand stars in our galaxy. There are a lot more in it that we don't see because they're just too far away for us to be able to see them as pinpoints of light. That's where that kind of cloud that we see in the nighttime sky, that's the band of our galaxy, that's the combined light from all of those stars that are too far away to see as pinpoints, we see as this kind of light glow in this band across our sky. So our galaxy is not alone. There are quite a few more out there. Now, the closest of these galaxies are in what we call the local group. And that's what I've just turned on here with these green circles. So our local group is a group of about 60 to 70 galaxies that are all kind of gravitationally bound together. The Milky Way is actually only the second largest of these galaxies. The largest in our local group is actually the Andromeda galaxy, and it's about twice the size of the Milky Way, or it has twice as many stars, I believe. And then The third biggest is the Triangulum galaxy, and all three of these are spiral galaxies just like ours. The rest of the 60 or 70 are really small galaxies known as dwarf galaxies. Now, our galaxy of the spiral is just one of kind of three types of galaxies that we can have. So we can also have elliptical galaxies, which look a lot like the globular clusters. They're just much bigger. They're galaxy-sized. And so these are roughly spherical, maybe slightly elongated sphere concentrations of stars. And then everything else that doesn't fall into either spiral or elliptical is what we call an irregular galaxy. And these are typically galaxies that have had a recent collision with another galaxy, or maybe just got a little bit too close and the gravity kind of tugged it out of shape. These are things that are in the process of some sort of change, whether, again, it's that collision, that close call, something like that. So as we continue to move outward, and we move through our local group, we start to see more and more and more as I've gone and just turned on all of the galaxies. As we keep moving out, we move through more and more galaxies, and more and more. I'll kind of turn us a little bit. And we keep going out. Now, you'll notice that these kind of distributions of galaxies, there seems to be something missing there in the middle. It's not that galaxies don't exist there. It's that in order to see galaxies in that direction, we have to look through our galaxy. And that's difficult to do because our galaxy, as we saw, has a lot of stars and gas and dust, and those block our view of what's outside of our galaxy. And so it's just our vantage or our view of those areas is blocked by our galaxy, so we can't really see what's there. But we do expect that those areas are filled just like the rest of the sky that we can see with galaxies. And so we keep going out, and we see even more and even more. There are hundreds of billions to maybe even trillions of other galaxies out there in our universe. And then as we keep moving out, we reach the edge of the observable universe. And this is what we call the cosmic microwave background. Essentially, what we're seeing here is the heat from the very, very early universe. And we call this the edge of the observable universe for two reasons. One, before the cosmic microwave background formed, the universe was too dense for light to escape. And so we just can't see any light from a time earlier than this. But we also have a limit on how far we can see based on the age of the universe. So our universe is about 14 billion years old, which means light has only had 14 billion years to travel from point A to point B. And so the only objects that we can see are those that are close enough for the light to have reached us in that 14 billion years. There could be a lot more even further out that we just don't see yet, simply because the light hasn't had time to reach us. So technically, every day that passes, we're able to see a little bit more of our universe. All right, and so with that, let's make our way back home as we fly back into this mess of galaxies. And back into our local group. Oops, I did a little early. Now we're back into our local group. Back into the Milky Way. Passing through all of the stars. Oops, let me turn all of these background stars off, just to make it a little bit easier to see what we're doing. Make it back to our sun, our solar system, and finally making it back home on Earth. So there you have it. That is the universe in roughly 30 minutes. Not so bad, right? So there we go. All right, let me switch back over now to us. And yeah, there we have it. A very quick tour of a lot of the things that we can find in our universe. There's definitely a lot more detail that we could go into about any of these objects that we have talked about. But hopefully you now have a good kind of overview of what's out there. Do we have any questions that have come through? I'm not seeing any.
Questions?
All right, well, if you do have any questions, now is a great time. Leave them down in the comments, and we will answer them in just a second when we see them. Since you're seeing a slight delay in what we're seeing. But while we wait for questions to come in, let me tell you a little bit about what our schedule is going to be coming up over the next couple weeks. So on Saturday, Lindsay is going to be telling us all about how animals and insects use physics in their everyday life in a show that we lovingly call Furry Physics. I love it. I think it's a great title. And there's a lot of really cool stuff in there. So you'll definitely want to come hang out with us Saturday evening and check that out and hear all of this cool stuff from Lindsay. And then next week, we are celebrating the dark skies that we have here in northern Minnesota with our virtual dark sky caravan, which will be going on all week, August 24th through 29th. Now, some of you may know that for the past 2 summers, we have actually taken our dark sky caravan on the road, taking our telescopes and portable planetarium with us as we travel up the North Shore. Unfortunately, we cannot do that right now. So we're moving the celebration online, and we have a lot of really fun stuff lined up. We are going to be joined by Starry Skies Lake Superior, who's going to tell us all about light pollution and efforts to keep our dark skies dark. We're going to be joined by Bob King, who's going to tell us a little bit about some of the things that we can see up in our dark skies. Jim Rock is going to be giving us an Indigenous perspective on the dark skies. And then Lindsay and I also have some fun stuff planned as far as kind of introducing you to telescopes, kind of some good entryway telescopes if you're interested in that. Lindsay's going to tell us about how to get into some beginner astrophotography, which is going to be a lot of fun. And then we'll also, one of the nights, tell you some of the cool things that you can get started looking at with your telescope and beginner astrophotography knowledge. And then each evening, we will also, if the weather permits, have a live stream through our telescope and look at the moon, Jupiter, Saturn, whatever cool stuff is up that we can get a good look at. So all that's going to be right here on Facebook Live. You'll find us all week, and we're very excited for this. And I saw that we did get a question.
Yep.
So from Honor, what's it like when galaxies collide? in a fast process, and what happens to the planets and stars in each galaxy? That's a really great question. So galaxy collisions are in no way fast, especially not from our perspective. They take hundreds of millions of years for this to happen, sometimes even longer. And as far as planets and stars, most of them don't really get affected because, as we saw, there's a lot of space in space. There's a lot of distance between stars. And so when two galaxies collide, what actually is happening is the stars mostly kind of pass by each other. Now, they can be tugged on by the gravity, their orbits may get changed, but they're not going to collide. You're probably not going to have solar systems that are disrupted or destroyed unless you're like right in the center of the galaxies where things are a bit closer together. And so it's not as much of a mess as you would expect from just hearing galaxy collision. And in fact, we are in the midst of a head-on collision with the Andromeda Galaxy. It's slowly heading our way and will collide with us in, I think it's like 5 billion years, Lindsay?
Yeah. About the same time the sun is going to end or die. So
yeah.
Not still.
So if
also,
we were, oh no, go ahead.
Instead of like a lot of star destruction, there would actually be a lot of star formation. Because the gas clouds that form stars are actually pretty big. And so when those collide, the stars are actually going to form when those gas clouds collide.
Yep. And that's when a lot of those kind of irregular galaxies we actually see tend to be very active, very quickly forming stars in a much faster rate than a galaxy that's kind of alone by itself because of that process. So yeah, it's pretty cool. And I personally love talking about galaxies. I know Lindsay does too. We both studied galaxies. I did my research in grad school on it. She's doing hers right now on galaxies. So it's definitely a topic we love talking about. All right, I am not seeing any other questions come in. So unless, Lindsay, you have anything else to add, we will wrap up for the night. So thank you, everyone, for joining us. We hope to see you again Saturday and definitely see you next week for our virtual Dark Sky Caravan. So until then, have a wonderful rest of your evening, and we will see you later. Bye.